applying KVL to loop I. Okay, so applying KVL to this loop I. So this, you know how to apply the KVL. So first sign is negative EI plus, then we have resistor R plus Ri plus L di by dt plus 1 by C I dt. This is the normal equation equal to 0. Then EI can be written as taking the Laplace transform equation 1 and 2. Sorry, equation 2 is very simple. Voltage across the capacitor E naught is 1 by C I dt. So E naught can be written as 1 by C I dt. That you already know. These equations in network, you have studied them. So taking Laplace transform of equation 1 and 2, because Laplace transform of output divided by input is the transfer function with no initial conditions. So we can write down this EI, can write down this S here. This is S domain. EI S here also. Okay. Oh, sorry, this is not, this is the equation only. I'm sorry. So for the timing, we'll write it. It's a T domain. So now we are taking Laplace transform. So this is in EI of S will be equal to Laplace transform of R is R only. I will be I of S plus it will be Ls I of S that we already know. Inductor is Ls and current is I of S plus 1 by Cs I of S. That's the equation. So we can bit a bit more calculation here. E of S will be I of S, we can take common. So there will be R plus Ls plus 1 by Cs multiplied by I of S. Okay, so next equation what we have, next equation is, can simplify this a bit more, or you can keep it like this, there's no problem. R CS LC S square plus 1 by I of S. So this is, let's call this equation number 3rd. Now E naught of S, taking the Laplace transform of this second equation, that will be second, that will be 4th equation. So dividing fourth by second by CS into CS will go up. This is multiplied by IS and CS will go up, divide, this will be IFS. CS and CS gets cancelled. Oh, sorry, we have written wrong. This should be E naught. E naught we have to take in the numerator. Yeah, that's wrong. E naught should be in the numerator, sorry. So E naught is what? I of S divided by C of S. So E1 will go, we'll take reciprocal of E1. So that will be 1 plus RCS plus LCS square into IFS. So IFS and IFS will get cancelled. CFS, CFS get cancelled. So transfer function E naught of s divided by ei of s will be equal to 1 divided by 1 plus RCS plus LC. I think we have done something wrong here. LCM is, this will be 1, this will be RCS. Why this is coming? Okay, just a second, just a second. R plus LS plus 1 by CS, fine. Okay, just a second, this is 1 by CS. Okay, this is RCS square. Yeah, I think this is correct. This is correct. There's no problem at all. RCS plus LCS square. RCS plus LCS square. Yeah, that's correct. There's no problem. Okay, fine. So plus LCS square. So this is the transfer function. This is what you have to find. Very simple numerical. Two equations you can take and you can divide. But always this will not be so easy. So let's go to the next problem. Find the transfer function of the electrical network shown in figure. Okay, so what we have, let's say in this case, in order to simplify this equation, we will consider this as Z1 and second as Z2, just for the sake of simplification. Okay. Let's consider this as Z1. This as Z2. Okay. So we can, Z1 we can write as both the combinations are in parallel, that is resistor and capacitor are in parallel. Laplace transform of C is 1 by Cs, R1 is R1. So 1 by C was by R1 divided by 1 by Cs plus R1. This can be further simplified. R1 by Cs divided by R1 plus 1 by Cs. So we can write, therefore, Z1 can be easily written as R1 divided by 1 plus R1 divided by 1 plus, sorry, just a second. So this is CS 1 plus R1 CS. Here I have written. Okay. Okay. So this is 1 plus R1 CS. So here it will be R1, Z1 will be R1, CS and CS will get cancelled. So 1 plus R1 CS. So this is Z1 we have got after the simplification. Now let's find Z2 now, then we'll see the series combination. Just a second. Z2 we know is R. Z2 we know is R2. So now writing the Kirchhoff's law KCL equation to the Z1 loop, sorry, KVL, applying KVL to Z1 loop. So what we are going to get, I think this is here VI. Just a second. This is VI, this is V0. So this will be minus VI plus Z1. Let's say the current flowing through this is I. So we can make a loop here like this. I. So that will be Z1I plus Z2I. That should be equal to 0. but we can write here further vi can be written as z1 plus z2 I. Let's substitute the values of z1 here. So take the Laplace transform of first. Okay. Now let's write the equation second now first. First we'll take the equation, then we'll take the Laplace transform. Second is voltage across the R2, that is Z2. V naught is I Z2. So now take the Laplace transform. Taking Laplace transform equation 1 and 2, we get Vi of S is equal to Z1. We can write Z1 as 1 R1 R1CS plus Z2. Z2 will write R2. I will be replaced by 1 by, sorry, I of S, that will be replaced by I of S. Further simplifying this equation. So Vi of S can be written as R1 plus R2, R1 plus R2 into 1 plus R1 CS divided by 1 plus R1 CS I of S. Vi of S is written as R1 plus R2 plus R1 R2 R1 R2 C of S divided by 1 plus R1 C of S. So this whole is multiplied by I of S. So let's call it equation number third. Now V naught of S can be written as, taking Laplace transform equation second, V naught of S can be written as R2 I2 of S. So that is equation number fourth. Add a page here. Okay, this was the equation number 4. Now transfer function, is the ratio of output to input. Transfer function is here output V naught of S divided by Vi of S, that will be equal to, output is, we can write R2 I of S. Sorry, it's not, current is common. It's not I of S. So R2 I of S divided by, so what is V1? So we can write it directly. R1 plus R2 plus R1 R2 C of S divided by 1 plus R1 C of S multiplied by I of S. So I of S and I of S will get cancelled. So this will go up. So transfer function can be further written as V naught of Vi of S can be written as, so we have R2, denominator will get multiplied, that is 1 by R1 CS divided by K. So this will be R1 plus R2 plus R1 R2 C of S. Okay, we can further simplify it by multiplying this. Just a second. Okay, this can be written as R2 plus R1 R2 C of S bracket close, divided by R1 R2 C of S. R2 will take common, so it will be 1 plus R1 SC. Same, just a bit manipulation we'll do. So here we can take R1 R2 common. In denominator we'll take R1 R2 common, so it will be 1 plus, just a second. Yeah, you can keep it like this, R2 1 plus R1 C, R1 plus R2, or you can take this common R1 plus R2 and then you can write. No need to do lots of calculation, but just for the sake I have done it. But if somebody will leave it here, answer will not be a problem. But this is a conventional examination. You don't have to find a precise answer as in the gate examinations. So that will be R2 divided by R1 plus R2. And this can be further written as 1 plus R1 SC divided by 1 plus R1 R2 CS divided by R1 plus R2. So this is your complete transfer function. Very simple. For this, we don't have to do much hassle till now. Simple equations of electrical engineering. Now let's find another numerical. So in the given network, find that now you have been asked to find the transfer function I2 of S divided by. So you have to take the appropriate equations. Now there's no choice. Whatever the transfer function, that means current in the second loop. Sorry, this is the current. Your current is here. Current in the second loop and voltage of the first loop, V of S. So division of these, you have to find the transfer function. Let's see now. Okay, solution of this. Now, in the given network, we will find the transfer function, but let us change that given network into the Laplace transform. We'll copy this. Copy. So we'll paste it here. Okay. So what we are going to do, we'll paste it here. So what will the first step? Okay, we can write the solution like this. First step in this solution is to convert the network into Laplace transform for impedances and circuit variables. Okay, and then at the same time, assuming zero initial conditions, we don't have to assume any initial conditions. Assuming zero initial conditions. So that's so we can convert this network into the Laplace transform. Very simple. How we will do it? Let us see. How to make a bit of manipulation. Okay. That's all we need. So this will become V of S. This will become VC of S. Okay. This will become L of S. LS. This will become 1 by C of S. So this is all the manipulations we have to do. And this will become I1 of S. And this will become I2 of S. So I will apply the mesh method. You will apply the homework for you is to, for the same numerical, you need to apply the nodal analysis. You can check it by the nodal analysis also. Or if you want, we can do nodal analysis. There's no problem at all. Okay. So any method you can apply. Okay. So let's apply the mesh method first. Writing the equations of loop 1 and loop 2 in matrix the matrix formed by inspection. So how we write it? R11, we know that how to write. So I will write it here. If you have to find the matrix, you can apply the nodal analysis, no problem. R21, R22, I1 of S. We will write directly by inspection. Sigma, sum of voltages in loop 1, sum of voltages in loop 2. So this is, what is R11? In this loop, we have only resistance and inductance. So circuit elements are R1 plus LS. So that will be R11. So here we will write R1 plus LS. Now what is common between 1 and 2? That will be negative minus LS. So minus LS will be common. Again 1 and 2 common is 2 and 1 same common minus L of S. R22, R2 plus LS. R2 plus LS. Oh, sorry, there's capacitor also, I think. Yeah. R2 plus LS plus 1 plus CS. R2 plus LS plus 1 by C of S. So this is by inspection. And then we have equations. V of S and we have 0. Why V of S? We have voltage source in only one. That will be in the direction of this. And then the second, we don't have any voltage because this is the voltage across capacitor. That's a different thing. Only the active element is voltage source we have in the loop 1. So that's what inspection we have. So what is our aim? Our aim now, we have to look into the what's the objective of the question. Objective is that you have to find I2 by Vs. So that means you have to find the current I2. So here we can write current I2 will be I2 of S will be delta 2 by delta. So what is delta 2? You replace the second column with delta. This is delta that we know by Cramer's rule. This is delta. Replace the second column by the right hand side voltage column. So R1 plus LS minus LS, and that will be V of S, and that will be 0. So this multiplied will be 0. Delta 2 we can write, this is 0, minus minus will be plus, so that will be LS V of S. Okay, that will be the value of delta 2. Now let's find the value of delta. Delta we already know. Delta is what? Delta is R plus LS, R plus LS minus LS minus LS, R plus LS plus 1 by C of S. So that's delta. Now let's multiply this. Delta will be, this is R1 and this is, just a second, this is what? This is R2. Yeah. Okay. So delta will be R1 plus LS multiplied by R2 plus LS plus 1 by CS minus minus plus will be L square S square. Okay. So let us further simplify this delta. Now, how you have to find the transfer function? You have to look into this I2. So that means obviously I2 has to be obtained. Delta will be, now further simplify this, R1 R2, then it will be R1, you multiply R1 LS plus R1 by CS. That is the first term multiplied with second term, R2 LS, and then it will be LS L square S square, then it will be S and S gets cancelled, L by C. S and S gets cancelled, L by C. Okay, so therefore delta can be further written as, we take the C square S as the LCM. Okay. R1 R2 plus R1 S cube, sorry, just yeah, no, S is the LCM, so C square S is the LCM, one of the S will go, so that will be S square only, sorry. Once again, R1 L, S and S gets cancelled because it is C square S is R1 L times, so that only figure will be multiplied, so R1 LC L C square and S square will be there. Okay, plus then it will be, if you divide this, then remaining figure will be C. So you multiply it by C. Plus here you completely multiply this, R2 L C square S square, plus here, yeah,
सर वहां
this,
पे 2 आता ना,
just a second, just a second, हमने कुछ मिस तो नहीं किया है? ये माइनस भी आएगा ना, एल स्क्वायर, जस्ट सेकेंड,
तो प्लस एस स्क्वायर,
एक मिनट, जस्ट यहाँ पे हमने कुछ गलती की है। एक तो ये मल्टीप्लाई हो जाएगा, माइनस एल स्क्वायर भी आएगा ना यहाँ पे, माइनस माइनस तो प्लस हो जाएगा, माइनस अपना ही आएगा, एल स्क्वायर एस स्क्वायर, सो यहाँ माइनस एल स्क्वायर एस स्क्वायर, इसको इसको कैंसिल ही कीजिए आप, ठीक है, तो ये तो हो गया, प्लस एल बाई सी को क्या लिखेंगे आप, सी मल्टीप्लाइड बाई सी एस, सो सी
से
एस
ऊपर वाला स्टेप समझाइए।
एल सी एस, कौन सा स्टेप ये?
तो ये जो आपने माइनस किया,
ये डेल्टा है ना, डेल्टा कैसे आपको मैट्रिक्स सॉल्व करना आता है?
सर नहीं,
दिस,
जो आपने एल स्क्वायर एस स्क्वायर जो लाया प्लस वाला,
आप यहाँ देखिए ना, यहाँ से इस ये टर्म है ना, इस टर्म को इसके साथ मल्टीप्लाई करना, ठीक है,
हाँ,
इज इट ओके?
यस
इस
सर।
टर्म को इसके साथ मल्टीप्लाई कर, माइनस माइनस प्लस हो जाता है, ये माइनस आ जाता है, सेकंड टर्म तो ये है, पहली
तो
टर्म,
लेकिन तो वो नहीं आएगा ना, प्लस एल स्क्वायर एस स्क्वायर नहीं आएगा ना?
ये माइनस आएगा, एक मिनट, ये फिर भी आ जाएगा आपको, सॉरी, ये माइनस गलती हो गई यहाँ पे, लेकिन यहाँ टर्म फिर भी आएगा, ये ठीक है अभी, ठीक है,
यस सर।
ओके, यहाँ तक ठीक है ना? तो यहाँ आप देखिए, ये एल स्क्वायर एस स्क्वायर आ रहा है कि यहाँ के नहीं, ये दूसरे का मल्टीप्लाई, पहले यहाँ दूसरी टर्म जो है R2LS, ठीक है, R2LS, फिर एल स्क्वायर एस स्क्वायर, ये तो ठीक है ना अब, ठीक है कि नहीं?
यस सर।
ओके, नाउ दिस विल गेट कैंसल्ड। तो कहाँ तक पहुंचे थे हम? दिस विल बी एल सी एस, हाँ ये इतना ही आएगा बस। तो डिवाइड बाई सी स्क्वायर एस। नाउ वी नीड अ ट्रांसफर फंक्शन, देयरफॉर ट्रांसफर फंक्शन हमें क्या निकालना है? ट्रांसफर फंक्शन वी नीड टू फाइंड इज आई टू ऑफ एस। तो हम देखेंगे क्या है, दैट इज डेल्टा टू बाई डेल्टा। डेल्टा टू क्या है हमारा? डेल्टा टू है हमारा, ठीक है, कहाँ गया हमारा डेल्टा टू? जस्ट सेकेंड, हाँ, एल एस बाई दैट इज वी ऑफ एस इंटू एल ऑफ एस। तो डेल्टा, ये टर्म तो नीचे आ जाएगी और सी स्क्वायर एस तो ऊपर चला जाएगा। तो विल राइट सी स्क्वायर एस ऑन द न्यूमरेटर, ठीक है, ओके दिस इज फाइन। तो डिनोमिनेटर में क्या आएगी आपकी टर्म? आर वन आर टू सी स्क्वायर एस प्लस आर वन एल सी स्क्वायर एस स्क्वायर प्लस आर वन सी प्लस आर टू एल सी स्क्वायर एस स्क्वायर प्लस एल सी एस। तो ये डिनोमिनेटर, बट सॉरी, हाँ हमें क्या चाहिए? हमें चाहिए आई टू, यहाँ से आप देखिए आई टू बाई वी ऑफ एस, तो वो निकल जाएगा यहाँ से। देयरफॉर आई टू ऑफ एस डिवाइडेड बाई वी ऑफ एस विल बी इक्वल टू व्हाट? सो यहाँ क्या आ जाएगा? ये हमने यहाँ लाया, तो दिस टर्म कैन बी रिटन एज एल सी स्क्वायर। यहाँ आप देखिए सी हर एक में कॉमन है, नीचे देखिए प्लीज, एक सी उसके साथ चला जाएगा, सी नीचे कॉमन लीजिए, एक सी उसके साथ चला जाएगा, तो यहाँ बच गया आपका एल सी एस स्क्वायर। एल सी एस स्क्वायर, क्योंकि ये ट्रांसफर फंक्शन हमें निकालना है, एक सी नीचे कॉमन है, दैट्स व्हाई आई एम राइटिंग सी, एक सी कट जाएगा, ओके। सो देन नीचे क्या आएगा आपका? आर वन प्लस आर टू एल सी एस स्क्वायर, एक सी चला जाएगा ना इसमें, यहाँ आप लिख लेते हैं हम, सम पीपल विल गेट कंफ्यूज्ड, इसको टर्म में दोबारा ही करता हूँ इसको, जस्ट अ सेक, इसको मैं, हाँ दीपी, तो यहाँ एक सी निकाले आप बाहर, ठीक है, तो फिर क्या बचेगा? एल सी एस स्क्वायर बच गया ऊपर कि नहीं? यहाँ भी एक सी आप कॉमन निकालिए, यहाँ क्या बचेगा? आर वन आर टू सी ऑफ एस, आर वन एल सी एस स्क्वायर प्लस आर वन प्लस आर टू एल सी एस स्क्वायर प्लस एल सी एफ एस में क्या बनेगा? एल एस। तो ये बच जाएगा हमारा, सी एन सी कैंसिल हो जाएगा। ओके, मूविंग फर्दर, तो therefore the transfer function I2 of s divided by v of s will be equal to what? c c कैंसिल हो जाएगा, तो न्यूमरेटर में आपका एल सी एस स्क्वायर आ जाएगा, इसमें तो कोई प्रॉब्लम नहीं है, दिस इज वेरी सिंपल। सॉरी, ओके just a second, ओके, एंड देन इट विल बी एल सी एस स्क्वायर। तो नीचे आप देखिए कॉमन क्या आएगा? आर वन यहाँ लीजिए, आर टू यहाँ लीजिए, कॉमन है ये, तो आर वन प्लस आर टू अगर आप लेंगे तो इसका कॉमन क्या है? एल सी एस स्क्वायर। यहाँ देखिए आप, दीज टू टर्म्स मैंने कॉमन लिए हैं, ओके। नेक्स्ट क्या ले रहा हूं मैं? एस को कॉमन, इसमें से एस आप कॉमन निकाल सकते हैं, सो दिस विल बी आर वन प्लस आर टू सी प्लस एल, तो ये इसमें एस कॉमन आ गया आपका, स्क्वायर है यहाँ पे, दिस स्क्वायर एंड प्लस आर वन आएगा, सो दिस इज व्हाट इज रिक्वायर्ड। इससे आगे सिंप्लीफाई नहीं करना, दिस इज फाइन, यू कैन कीप इट अप टू हियर, ठीक है। ये इतना सिंप्लीफाई अगर करेंगे आप तो ठीक रहेगा, इतना भी कर लेंगे, कैसी किसी को कैंसिल कर लेंगे तो दैट इज ऑल्सो फाइन, नोबडी इज गोइंग टू बॉदर अबाउट दिस, क्योंकि ये सेम है। तो लेट मी बॉक्स इट, दिस इज द रिक्वायर्ड ट्रांसफर फंक्शन, this is the required transfer function, we were looking for. Okay, next is, okay, you can, for your homework, you can use same, uh, for your homework, apply the nodal analysis for the same question. That will be your homework. So I will write it here. Homework for you is, homework is solve the same question using nodal analysis technique. Okay, this is fine. Okay, next question is, just a second. Yeah, I think मैंने question नहीं लिखा है यहाँ पे. Okay, I will write down. This was number what? 4. This is a problem number 5. Simple है ये. Problem number 5. What's the problem? Find the transfer function that is given here is Vc of S by V of S. So this is the transfer function you have to find for the circuit shown, but he has precisely given use nodal analysis now. Use nodal analysis technique. Okay, let us use the nodal analysis technique. Okay, let's find the solution of this one. Solution of this is, this you can say the voltage, sorry, in the question R1, R2, yes. Let me check. Yeah, voltage has been given here. This is VL of T. Yes. Vs, let me check the question again. R1, R2, C. No. Yeah, fine. This is Vc of T and this is C. Okay. What we will do first, we will, first step is to convert the network to Laplace transform. You have to find the, you have to you have to convert the network into Laplace transform, for you have circuit variables and then we have voltage sources, whatever the circuit variables we have, and any impedance is there, and we have to convert this. Let us convert the sorry, convert the network into Laplace transform. Okay, for circuit variables and impedances. Okay, so let's convert this. So we can manipulate this a bit. Here, instead of V of T, we will write 1 by C of S. and you can write this voltage V of VC of S here. Similarly, this is V of S here. You can write this is VL of S, and this will be L of S. This will be 1 by C of S. So this is the Laplace transform. We have converted all the variables and then impedances into the circuit elements. Basically, or whatever the circuit elements are present, we have to convert them into equivalent Laplace transform values. Okay, now applying node at VL, or we can say applying KCL at node VL. So this is node VL. So this is the node VL minus V of S. And what's the impedance? Impedance is resistance only. Just a second. I think there is some problem with the question. This is some different question. I don't know why I have taken this. Let me check. Yeah, I think we have solved the previous homework. मैंने क्या दिया था? तो यही है वो. I think this is the same question.
यस सर सेम, मगर उसमें था वो I2 of S by V of S.
ठीक है, leave it now. Then you can solve it. ठीक है. मैंने
Okay,
शायद
sir.
उसी को कॉपी किया है. Sorry. You can do it. I think by nodal analysis है ना?
यस सर यस.
कोई बड़ी बात नहीं है. ये सेम क्वेश्चन हो जाएंगे. रिपीटिशन हो जाएगा ये. I don't like this. इसको मैं छोड़ देता हूँ यहीं पे. You can solve this later on. We'll solve this numerical. It's a good numerical. So question here is find the transfer function this. So I will solve it by one method. You solve it by another method. This is your choice. So again, we'll write the solution for this one. Now convert, in order to find the solution, convert the network convert the network impedances and circuit variables. Assuming again zero initial conditions. That is necessary in this case also. Now let's copy this figure. Okay, copy. Okay, now let me write the values first. Okay, so this will be S, LS, because L is 1. So this will be 1 and 1. Resistor value will remain the same. This is again S, and this will be VL of S. This is again V of S, and this is, let's say this current is I1 of S, I2 of S, and this is I3 of S. And again here we have S because value of L is 1. Okay. Now again, writing equations in matrix form by inspection. Simply we can write again. So loop 1 will be s plus 1 plus 1. That we can simply write s plus 1 plus 1 is s plus 2. So we don't need to worry about this. So I can directly write this is s plus 2. Okay, next. This is same like R11, R2. 1 and 2, what's common between 1 and 2? This is 2, this is 1. 1 is common, that is minus 1. R11, R12, R12, R13. What is common between? Just a second. Why we are writing 0 here? R11, R12, R12, R13. So what's common between 1 and 3? Yeah, this is minus 1. Again. Okay, now second loop. Sorry. R22 is what? So we have 1 plus s. That's first we have, sorry, R21. R22 and R23. R21. 2 and 1, what is the common? 2 and 1 common is again same, minus 1. And R22, all the elements of the loop 2, s plus 1. So we'll write down s plus 1 here. R21, R22, R23. Between 2 and 3, minus s. Common is minus s. Okay, now coming to the third loop. R13 between 1 and 3, common is minus 1. Between 1 and 3, between 2 and 3, minus s. And summation of the elements of all s plus s is 2s plus 1. We are writing by inspection. We don't need to write the I1 of s. K 0 VSN 0. Okay. Now next is, what is the objective here? Let's look at the objective. What's the objective we have? Just a second. We have to find VL of S by V of S. VL of S by this voltage. So what we are going to get in delta I3, we are going to get delta 3 by delta. So I3, we are going to get delta 3 by delta. Let's see what we are going to get from I3. How I3? Because this I3 is flowing through the VL of S. So something, the voltage VL of S will be multiplied by I3 of S into the impedance. So something will come out with VL of S. That's why we are choosing the current I3. Now let's write down here. I3 of S will be delta 3 by delta. Now let's add a page to this. Okay, now delta 3 is what? Replace the third column with the voltage column on the other side. So 0 Vs 0, we have to replace it. S plus 2 minus 1 minus 1. The first column is, just a second. Okay, so this is S plus 2 minus 1 minus 1. And second is minus 1. S plus 1 and minus S. And the voltage column is only voltage is present in the second loop. So if you solve this, leave the first, which is equal to s plus 2. Leave the first row and first column. This will be 0. Minus minus will be plus s into vs. So this is s into v of s plus 1 minus second sign is 1. Column and row you have to leave 0. Minus minus plus v of s. And third is 0 itself. We don't have to take it. So we can simplify this. S into s plus 2 plus 1. Okay, because we'll take vf common. S, this is s here, multiplied by s plus 2 plus 1 into v of s. We can take it like this. So this further can be written as delta 3 can be written as s square plus 2s plus 1 into v of s. So let us see, this is delta 3. Let's solve the delta. Delta is same. Delta is what? Sorry. S plus 1 minus 1 minus 1. Then second column is same also. Why we should copy this? Can use. We'll copy this. Why to make? This is your delta. Copy and paste it here. Paste. Okay, so this is your delta again. S plus 2 minus 1 minus 1 minus 1, s plus 1 minus s, and then minus s and 2s plus 1. Okay, let us solve this delta. Just a second. So this will be first row equal to s plus 2. Leave this column, leave this row. S plus multiplied by s plus 1 into s plus 1 minus s square. So this will be s plus 1 into 2s plus 1 minus s square. So that is first minus minus plus 1 multiplied by, leave this row and leave this column. That will be, leave this row and leave this column, minus 2s plus 1 minus minus plus will be s. Sorry, minus minus plus will be minus s. Okay, this row and this column we have left. This is minus multiplied by this is minus 2s plus 1 minus minus plus will be minus will be plus, and minus will come out. Minus will become with the sign. Last is minus 1, and that will be, leave this row and leave this column. That will be plus s minus minus will be plus s plus 1. So let us simplify this. S plus 2 can simplify this here. So this will be 2s square plus s plus 2s plus 1 minus s square. So here we have 1, no need to write this, minus 3s minus 1. Here we have 2s minus 1. Simply sign we have to multiply. So this can be further written as s plus 2. This will be s square plus 3s plus 1. Okay. So this will be minus 5s minus 2. Okay, further we can write this. We can multiply this now as 1. S cube plus 3s square plus 3s square plus s. 2s square plus 6x plus 2 minus 5s minus 2. So if you solve this, s cube is alone. So 5s we have plus 5s square. Fine. No other square term. S term. 6 and 1 is 7. 7 minus 5 is 2. So 2s. 2 and 2 gets cancelled. This 2 and this 2 gets cancelled. So we have this coming out to be, we can further keep it as s square plus 5s plus 2. So that is your delta. Therefore, your I3 of s will be delta 3 by delta. That can be further written as delta 3 is what? Just a second. Vs s square plus 2s plus 1. Okay. So this is s square plus 5s plus 2. Okay. So from loop third, we have VL of S. You can see very clearly the voltage across the capacitor here, sorry, inductor, S into I3. I3 of S. So I3 of S is what? S into V of S. Then we have S square plus 2S plus 1 divided by S into S square plus 5S plus 2. So this we have here. Okay. So S and S gets cancelled. So I3 of S. So what we have to find basically? Okay, we have to find VL of S. So here you can see, here it is VL of S. S and S gets cancelled. VL of S by VS. I will add a page. VL of S by VS. Yeah, VL of S by VS. S and S gets cancelled. So this will be S square plus 2S plus 1 divided by S square plus 5S plus 2. So that's your complete transfer function. Anybody has a doubt? So that's all. I will stop the recording first.